Find the derivative of the integral of that function. Well, how are we going to do that? Well, it's all about fundamental theorem of calculus, which says that if you go the integral from anywhere to x of some kind of function of t dt, what it'll equal, well, actually, if you then you take the derivative of that, what'll happen is the derivative will cancel out the integral and the dt at the back is part of the integral, and you can just plug in the x, so it'll be f of x. The x will go on the inside. You tracking with me? So that's the fundamental theorem of calculus discovered by Newton and Leibniz around the same time in the 1500s, I think it was. The derivative and the integral are opposites. People were doing derivatives and integrals for a long time, but they didn't know they were opposites. That was the big discovery, what we call the fundamental, most important theorem of calculus. Derivative and integral are opposites. So they cancel each other out. And then you just take that top. The bottom number doesn't matter at all. The 6 isn't going to matter at all. The top, though, matters. And you just plug that in. That becomes the inside. The derivative and integral cancel each other away, including the dt. That's part of the integral. They all drop off. Just take that x on the top, plug it in. Doesn't matter what that bottom number was. Throw it away. Who cares? F of x. There we go. But, okay, yeah, but what if the top is not a simple x? What if instead it's 5x? Well, you might think, well, same thing. Just plug in 5x. Yeah, but remember, we're doing a derivative, right? And what have we learned about derivatives? That whenever you take the derivative, if the inside, the thing you're plugging on the inside, is anything other than a simple x, the chain rule gets involved and says you got to multiply by the derivative of the inside, which would just be 5. Derivative of 5x is 5. So that's going to be the real way we do this problem. So we have both the chain rule and the fundamental theorem of calculus both interacting here. So the derivative of the integral cancels out. You just plug in the inside. But if that inside is anything other than a simple x, because we're doing a derivative, chain rule says keep the inside the same at first, but then multiply by the derivative of the inside. Derivative of 5x would be 5. So that's what we do. So we're going to go, okay, here we go. We don't care about that part at all. Take that 5x, right? This derivative cancels this integral, this dt is part of it, and just plug into the t right there. The root's still there, all the rest of that stuff's still there. 1 plus, but then instead of t to the 10th, it becomes 5x to the 10th, right? You're plugging the 5x into the t slot. Okay, but then times, because of the chain rule, what this is the inside, this is what we plugged in. Chain rule says you got to take the root of the inside, the thing you're plugging in, and that'd be 5. That's why we have this 5 outside the root. It's multiplied after and outside the root. And there's the rest of it. That's our answer. There we go.